Hello. For today's lesson, I am teaching about Intro to Geometry. This curriculum is designed for ages 11 through 13 or 5th grade to 7th grade. All right, let's begin. So the summary of this lesson is you will learn about lines, 2D shapes, and 3D shapes, and how to find the area and volume of those shapes. So the skills that you're going to learn are formulas for area and volume, learn math vocabularies, identify different kinds of shapes and lines. And also, this lesson is split into two sections. One section for the 5th graders, and another section for 6th through 7th grade. All right, this is Interns for Good, by the way. All right, next, 5th grade. Some math vocabularies you can learn are points, the exact location. A point has no size and is represented as a dot. A point could also be named with a letter, mostly a capital letter. Next word we have is segment. A segment is 2 points that are connected by a line. A line is basically a line with arrows at both ends, meaning that it stretches in both directions forever. Rays. A line that starts at one point, meaning the line only stretches, meaning a line that starts at one point, meaning the line only stretch in one direction forever. Vertex, or the plural form is vertices. A vertex or vertices are a vertex is the point where two or more rays and segments meet, or a vertex could also be the corner of a shape. Perpendicular. Perpendicular means at a 90-degree angle. For example, like perpendicular means at a 90-degree angle and could occur between crossing/intersecting lines. Parallel. Parallel means that something will never cross, intersect, or touch. So here we have our examples of the vocabularies above. So the vocabulary is on the left and the corresponding example is on the right. So point, we have here point A. Segment, we have a line, 2 dots, 2 points connected by a line. And then we have the vocabulary line, which is a line that stretches in both directions forever. And we have a ray, which starts at one point and then stretches in one direction forever. Then next we have vertex. So right here, this is a rectangle with a vertex being shown. Perpendicular, on the right side, we are that is 2 lines intersecting at a 90-degree angle. And then we have parallel, 2 lines right there that are never crossing. Okay, we have some practice. So I practiced about identifying the vocabulary being shown. So basically, you're going to be given options A, B, C, and D, and then you select whichever one is being shown in the picture. And also, if a lines appear to be perpendicular or parallel, they are. So the first problem we have is a dot is a point and a line that stretches in one direction forever. So the options we have are A, vertex, B, ray, C, point, D, segment. And then the next problem we have, the next image we have is 2 lines that are 2 lines. I'm not going to try to spoil, but let's just say there's 2 lines. And then the options we have are A, parallel, B, perpendicular, C, line, D, vertex. And if, oh wait. Oh yeah, by the way, if I'm not giving if I'm not giving you enough time, then you can just pause the video and come back. Okay, so 3, 2, 1, pause the video. All right, welcome back. So the answers you all been waiting for is here. So the first problem, the answer to it is ray, because there's a point right there, and then a line stretching in one direction forever. And then the next problem is, the correct answer is A, parallel. It is parallel because I didn't tell you guys this, but if two lines or any amount of lines um have this arrow thing between it, it means that it is parallel to the corresponding line, like this. All right. Next images. So this image is a dot and then a capital letter. So the options you have are A, perpendicular, B, line, C, vertex, D, point. The next image we have is a triangle and then an arrow pointing at a point right there. So what is that point called compared to the triangle? So the options we have are A, ray, B, line, C, vertex, D, segment. All right, I'll give you, let's pause. 3, 2, 1, pause. And you're back. So once you know the answers, you can just unpause it and then I'll be here. All right, so the answer to these images are, for the first image, we got point because it's a dot and it's being labeled by M, so that point could be called M. And then the next image is C, vertex. It is a vertex because it's a corner of a shape. There you go. All right, we still got more. So next. All right, so the first image we have is two lines intersecting with a square between one of the angles. And then the options we have are A, segment, B, rays, C, parallel, or D, perpendicular. The next image we have is two dots that are being connected by a line. So press pause if you need more time. Actually, press pause and then come back once you have the answer. All right? 3, 2, 1, pause. Hello, welcome back. Okay, so I'll show you guys the answers right now. So the first image, the answer is D, perpendicular. So I'm not sure if I told you guys this, but if two lines are intersecting or like an angle is there and there's a square between the two angles right here, that means that angle is a 90-degree angle. And then the next image we have, the answer is B, segment. So it's pretty obvious. So two dots, 2 points connected by a line. Next equation. Next images, I mean. All right. So the next image we have is two lines going outward, but then are connected by a dot right here. So the options you have to identify this is A, vertex, B, perpendicular, C, parallel, or D, lines. The next image we have is pretty easy, so I'm not even going to try to say anything. You guys probably can get it. So the options we have are A, segment, B, vertex, C, ray, and D, line. So pause the video If you need more time, 3, 2, 1, pause. And welcome back. The answer to these two images are, first answer, the first image, the answer to the first image is A, vertex. It is a vertex, and it could be two ways if you really think about it, but the arrow is not pointing at the two lines, so Ray can't be the answer, even though there's no option Ray as an answer. It is a vertex because it's connecting these two lines right here. There you go. Or it's the endpoint of these two lines. And then the next one we have, the answer to this one is C. Oh, wait. Nope, my bad. It's a scratch. It's not Ray, it's a line. So, my mistake, guys. The answer is D, line, not C, Ray. Next image. So, the next image we have is similar to the last one. So, it's this line right here, has the endpoint right here, and then this bracket is asking what this part is. So the options we have are A, ray, B, vertex, C, line, D, segment. The next image we have is a rectangle, and then we have some arrows right here on this line, and the arrow right here on this line. So you just gotta identify what these two lines are, like what are they representing. So pause. 3, 2, 1, pause. And welcome back. Here are the answers. For the first image, the answer is ray, because the line starts at one point and it stretches out in one direction. The next image, the answer to it is parallel. Remember, last time I told you that these arrows right here representing these lines, right? I mean, these arrows represent parallel. Represent that the line or whatever that the line is parallel. There you go. All right. Yep, good job, of course. All right, information about area. So we're gonna move into area. Area. You might ask, what is area? So area is the amount of space a flat shape or 2D shape, aka two-dimensional shape, or the surface of an object is taking up. The measurements, so when you're doing area, you want to measure it in units squared. So some examples of a unit squared are inches squared, inch squared, centimeters squared, feet squared, meters squared. So what are 2D shapes, you might ask? So these are some 2D shapes you might see. All right, next. So you might ask, what is the difference between a 2D shape, between 2D shapes and 3D shapes? So here are created 2D shapes on the left side and 3D shapes on the right. So these are 2D shapes and these are 3D shapes. Can you tell the difference? Yes. Dude, the 3D shapes looks like something you can grab, carry, touch, or like push and stuff. Yeah. So next lesson we're learning, the next unit we're learning is quadrilaterals, quadrilaterals. So you might ask, what are quadrilaterals? And I say to you this. Quadrilaterals are 2D shapes / figures with 4 sides, 4 vertices, forming 4 angles, and all the angles will collectively form 360 degrees. So some examples of quadrilaterals are squares, rectangles. Here, let me pull this up. All right. So some examples of quadrilaterals are squares, rectangles right here, trapezoids, kites, and yeah. Oh yeah, this is a parallelogram. Parallelogram, by the way. It's also a quadrilateral. So I have a quadrilateral song that you can listen to that I did not create this. Some YouTuber created this. It was pretty good. I watched it. So let's watch it. Here. Oh, wait. Here, watch this on YouTube. And then
I'm excited. Let's see what's inside.
Skip this ad.
I really like the build. It's
Alright, you cannot see this video currently, so I'll just leave it in the link below. Find the presentation. I'm sorry guys. Yeah. Alright, let's get back to the presentation. Alright, even though we couldn't see the song, it's so sad. It'll be at the end of the presentation, appendix section. So let's move on. What do you need to know for squares and rectangles? So what do you need to know about squares and rectangles? So squares are always rectangles, but rectangles are not always squares. This may be confusing, but stay with me. And then we gotta know that squares are a special type of rectangle where all the sides are equal to each other, aka / congruent. New word. Congruent means equal, basically. And then we have rectangles and squares have 90-degree angles on all 4 of the vertices, or all 4 of the angles. How to find the area of squares and rectangles. So the formula for the area of rectangles and maybe squares, but like I have a shorter version, but you could use this formula for squares and rectangles. It's fine. So it should be length times width. Length right here times width. Shortened version is L times W. Notice that the units are in units squared. The units are in units squared. So keep that in mind, because when the teacher tests you, you might get marked off because you didn't put your units in squared. So yeah, remember, it's really important. How to find the area of squares. You could use length times width like some people, but you could use this formula. So we got area equals S squared. If you're wondering what S is, it's obvious. It's right here. S is side, is the side. Since we know that all the sides of a square are congruent, we could just take one side and square. That means that'll mean the side will multiply to this side. So it'll get the area of the square. We squared a measurement of okay, we already went over this. Okay. So let's get some practice in. You might need a piece of paper and a pen / pencil or some writing utensil. And let's start. Activity number 1. So this will be an example of what you're gonna do. So I'm gonna explain this. So find the area of this rectangle with the length of 6 centimeters and 4 centimeters. The answer. So basically I put length times width, and then I plug this in. I plug these numbers into the formula, aka substitute. So it'll be 6 times, so it'll be length times width, right? 6 is the length, so 6. 4 is the width, so 6 times 4 equals 24. 24 centimeters squared. All right, now it's your turn. All right, so pause the video, do whatever your work. Once you're finished, come back, and then I'll show you the answers. So 3, 2, 1, pause. And welcome back. So here are the answers. So we got the square with the 8 meters on both sides. But if you realize that all the sides are congruent to each other, then you could use this equation. A equals S squared, or area equals side squared. So one of the sides are 8 meters. So we just put A equals 8 squared. And then we do A equals 64. Because once you square it, 8 equals 64. So the area should be 64 meters squared. Next equation. So we have a square here with 24 feet. So pause the video, do whatever you need right now. 3, 2, 1, pause. And welcome back. Oh well, all right. So recap, we have a square with 24 feet as a side. So we'll use A equals S squared, area equals side square. And then we should plug it in 24 feet, plug it in to S because it's a side. And then it should be area equals 24 square. And and then once you square the 24, it should equals to 576 feet squared. Next. All right, so next problem is find the area of this rectangle. So we have a length of 14 inches and then a width of 9 inches. So pause in 3, 2, 1, pause. Hello, and we're back. Okay, so the answers are, so I show my work, so we do length times width, because it's a rectangle. So you plug in 14 into length, 9 into width, 14 times 9 equals 126 inches squared. All right, so now next, find the area of this square with a side of 13 centimeters. So pause in 3, 2, 1, pause. And what's up? We back. Now the answer to this problem is, I show you my work. So we got A equals S squared. So area equals side squared. And then you plug in the 13 into the S, because plug in 13 as the side. And then you get area equals 13 squared. And you square the 13 out. If you don't know what square is, basically just take the number and then times it by itself. So 13 times 13 equals 169 centimeters squared. All right. Now this would end the 5th grade section of this curriculum / lesson. So now we're on the 6th to 7th grade section. There you go. Next. So I added four more vocabularies to this vocab list. So just in case you skip to the 7th, just in case you skip from the beginning to the 6th to 7th grade section. So I'll just go over this again and let's do this. So the first vocab we got is point. So a point is the exact location. We know that it has no size and is represented as a dot. So a point could be named with a letter, mostly a capital letter. And then next vocab we got is segment, 2 points that are connected by a line. Next the next vocab we got is line. A line is a line. It's kind of weird, but a line is a line with arrows at both ends. So basically it means that this line stretches in both directions forever. Now, in contrary to this, we have, if a line stretches only in one direction, we call that a ray. A ray is a line that starts at one point and then it stretches indefinitely in one direction. Next we got is a plane, not the flying plane, but like the plane dimensional plane thing. Yeah. All right, a plane is a flat 2-dimensional figure that stretches infinitely far, my bad. So it has no thickness. A plane does not have thickness, and it is two-dimensional or 2D. 2D. There you go. So the word that I've been using lately is congruent. So congruent means congruent means equal. Equal right there. So the next thing we got is vertex. So the plural form of vertex is vertices. A vertex is a point where two or more rays or segments /segments meet. A point could also be considered a corner of a shape. Next we have perpendicular. A perpendicular means at a 90-degree angle and could occur between crossing/intersecting lines and could be shown, actually, yeah, that'll work. And then we got parallel. Parallel means that something would never touch, cross, intersect. So this could be like lines, planes right here. Planes could be parallel. And then next we got complementary. So complementary is when angles add up to 90-degree angle. Supplementary is when angles add up, two angles, I believe it's two angles, add up to 180 degree. Next. So I create some examples of the vocabulary so you can, just in case you're a visual learner. So here you go. So point is right here, a dot, and then a capital letter. A point named as we have a segment, two dots, 2 points, connected by a line. And then we got line. So we got a line right here, stretching both ways, two direction, infinitely, I mean. And then we got array, only stretches in one direction, but starts at this point. Next, we got vertex. So we got a square. No, that's not a square. That's a rectangle. So we got a rectangle right here, and then a dot representing the vertex. So it could be the corners. Could be this right here. A vertex could also be this corner vertex. Yeah. Could be this one too. Could be this one. I'm just doing this one as a visual to see where it is. So next we got perpendicular. So we got here are two lines that are intersecting with each other, and they create a 90-degree angle. So this is what you call it when two lines are perpendicular. Next we got parallel. Parallel right here is two lines. This is represented by two lines. They are not intersected at all. So that means they will never cross, they will never touch, intersect, or whatever. Yeah. So next we got this. We got a plane. Not this kind of plane. Not the flying plane. All right. So we got this plane. So a plane is represented with this kind of parallelogram looking object shape, but it's basically just extending in all directions forever, infinitely, right here. Complementary. So remember when I said when angles, or two angles actually, add up to 90 degree. So this square box thing between this line and this line is telling us that in this angle right here is a 90-degree angle. And then this line intersects between the 90-degree angle, creating two angles that add up to 90 degree. Next, we got supplementary. So right here. So this whole straight line is a 90-degree angle. So if you ever see a straight line like this, like a legit straight line from here, it means that this angle, it means that the angle of this line is 180 degrees. And then this line that goes out of it creates two angles that add up to 180. So let's get some practice. So the practice right here is to identify the pictures being shown in the vocabulary I just showed you guys. So, all girls, guys and girls. All right. So the first image we got is this. this right here. It's pretty obvious. And then the options you have are A, line, B, segment, C, ray, D, point. The next image we got is this one. So you got a dot and then a line stretching infinitely in one direction. So the options we have here are A, segment, B, ray, C, supplementary, and D, plane. All right, so I'll pause the video and let you guys do the work. Finish figuring out this in 3, 2, 1, pause. All right, what's up? Hello. So you're back after figuring out this. This is pretty easy. So the answer to this is the first image we got is a line, because it's a line that stretches in two direction infinitely. And then we got a ray right here, starts from one point, stretches in one direction. And the answer to this should be B, ray. Next, images. So this image we got what seems like a parallelogram, but I did not teach you guys this, so like think about the vocabulary. So this thing stretches this way, and this way, and this way, infinitely. So it stretches in all directions infinitely. And then has points on here that is labeling this thing. And then the next image the options for this image is A, complementary, B, segment, C, plane, D, line. Next image we have here is two lines and this an arrow on each of the line, which if you guys can remember what I taught you guys or like stated, then you get the answer really quick. So we got A, perpendicular, B, parallel, C, points, D, rays. All right, just pause the video, and once you guys are finished figuring this out, then unpause it, and then I'll meet you guys there. 3, 2, 1, pause. And welcome back. We are here. So the answers to these two images are, the first one is C, plane. Remember, a plane is being shown as a 2D shape like this, and it stretches in all directions, even though I can't show you it, and it's being labeled by 3 points. Because usually when you label a plane in math, you need at least 3 points right here. At least 3 points to name it. Or unless you have like 1 point and then it has a number, or actually a letter. Next we got is parallel. This image is showing parallel. These two lines are parallel because even though they don't look parallel, these two arrows right here makes them parallel. Just know that. Next two images. So the first one we got is a line right here, and then a line that goes out of it. So the options we have are A, complementary, B, line, C, supplementary, D, parallel. And then the next image we have is two lines intersecting, and they create this thing right here. So the options you have are A, parallel, B, perpendicular, C, vertex, D, complementary. So pause the video as we did. 3, 2, 1, pause. And welcome back. So here are the answers. So for the first one, we got supplementary because the straight line is showing a 180-degree angle. And then this line right here that goes out of it is splitting the angle into two different angles that add up to 180 degrees. And then for this one, we got two lines intersecting each other, and they create this square thing in the angles. This is showing that this intersection is a 90-degree intersection. So we got perpendicular, B. Next problem, we got next image. Next image we have here is two points connected by a line. And then the options you have are A, segment, B, point, C, ray, D, complementary. And then the next image we have here is two lines that have the same endpoint. So the options are A, complementary, B, supplementary, C, vertex, and D, perpendicular. So as the usual method we've been doing. So once you pause it, return. All right, 3, 2, 1, pause. Hello again. So the answers we have here are bam. So the first image we have here is A, segment. The answer is A, segment, because it is 2 points connected by a line. Next we have is vertex, because it's 2 lines right here that has the same endpoint, creates a vertex. Next practice. So the first image we have here is a line that is creating this angle right here, and a line that goes through it. So the options you have are supplementary, complementary, parallel, and line. Or A, supplementary, B, complementary, C, parallel, D, line. The next image you have is a triangle with this, a triangle with the square between one of the angles. So I'm gonna say it's a right triangle. So the answer for this one has to do with the two angles that are not right, or like not 90 degrees. So the two angles on this side and this side right here, which is being blocked, it has to do with the answer. So I'll give you, so just pause, and when you're ready, come back. So 3, 2, 1, pause. Hello. Hopefully you guys got the answer for the second one right here, the triangle one, because it was kind of difficult, quote unquote. All right. So the answers for the first image is B, complementary. So basically it's a 90 degree right here, and then it's being bisected. No, not bisected. It's being intersected by a line right here. And it splits the 90 degree into 2 different parts. So we have 2 angles right here that add up to 90 degree. The next image we have right here. So it is complementary. And you might ask why. So if you don't know already, a triangle is all the angles in a triangle add up to 180 degrees. Since this angle right here at the bottom right here that's being covered is a 90 degree. So if you subtract 90 degree off of 180 degree, then you get the other 2 angles have to equal to 90 degree. And remember, complementary means that 2 angles add up to a 90 degree. So this angle and this angle right here add up to 90 degree. So we get complementary. So next we're moving on to triangles. Information about triangles. Yay. So there are different types of triangles, if you haven't noticed. So we got an obtuse triangle. So one of the angles in the triangle is over 90 degrees. We got an acute triangle where all of the angles are less than 90 degrees. And then we got a right angle, which was mentioned from the slide before. So one of the angles in the triangle is equal to 90 degrees. So here are the pictures. Oh wait, no. Yeah, as I said right here, I was mildly confused about what I did, but like, I understand now. So you know how there was a square between the angle? That means it's 90 degrees. Yeah, basically. Here are the pictures. So we have obtuse. See, this angle right here is over 90, so it's obtuse. Acute, all the angles here are less than 90 degree right here. And then we got a right triangle. See, one of the angles right here in a triangle is a 90 degree. The square right here represents a 90 degree angle. All right, next. But there's more ways to classify a triangle. So we have more types of triangle. This time we are classifying them based on the side, based on their sides. So we got a scalene triangle where each of the sides of the triangle have different lengths. We got an isosceles triangle where two of the sides of a triangle are congruent to each other. And then we got an equilateral triangle. All of the sides of a triangle are congruent to each other. So here we have a scalene triangle where all the sides have different lengths. So 8, 12, and 15, they're not the same length. An isosceles triangle, so we got 10, 10, so these makes it isosceles, and we got 12 right here, which is different from these two. And then we got equilateral, so we got 8, 8, and 8, so all the same. And by the way, if you haven't noticed, I'll tell you one fact is that within that, no, I'll tell you later. Next. So we have an activity, yay. So just classify the type of triangle being shown. So when you classify a triangle, right, you want to classify them on the side and the angle too. So both of them at once. So here, I'll give you an example if you're confused. So we got this triangle right here with 10, 10, 12, 35, 35 degree, 110 degree. All right. So I would classify it as an obtuse isosceles triangle. It is obtuse. Okay, first off, if you're questioning why you identify the triangle first with the angle, so you identify a triangle with the angle first and then the side first. So here we have obtuse. The triangle is obtuse because one of the angles are over 90 degrees. So this one right here, 110 degrees. And it is an isosceles triangle because it has two congruent sides, so 10, 10. Activity. So, oh yeah. So now it's your turn. So now identify the triangle being shown. Remember all the vocabulary we learned and then try your best. So pause it, and then once you finish, unpause it, and I'll be back. So 3, 2, 1, pause. And welcome back. I hope you guys can identify this. If not, it's okay. We got more practice to go. So the answer is acute scalene triangle. It is acute because all the angles right here are less than 90. It is scalene because all the sides are not equal. They're not the same. None are equal or congruent, I should say. Next triangle right here. So we got 11, 11, 11, 60, 60, 60. So pause, 3, 2, 1. Welcome back. Okay, here are the answers. You might have noticed a pattern in this triangle. So here, let's give the answer. So it is an acute equilateral triangle. It is acute because the angles are less than 90 degrees. All the angles are less than 90 degrees. And it is equilateral because all the sides are equal to each other. And if you notice this, if all the sides of a triangle are equal to each other, that means that the sides are also all equal to each other. And the opposite way around too. If the sides are all equal, then the angles in the triangle are all equal. So this could be like, yeah. So an equilateral triangle always has a 60-degree angle for each of its angles. Next triangle we have here is a triangle. Yes. Here you go. So pause the video in 3, 2, 1, pause. Hello, and we're back. So let's review the answers. So this triangle is an acute isosceles triangle. So it is acute because all the angles are less than 90 degrees, but it is isosceles because two of the sides are congruent to each other. And you might have noticed this pattern or not, but it's fine if you haven't noticed that if a triangle is isosceles, if you notice this, that isosceles triangles, that the two angles right here are equal. Always in an isosceles triangle, two of the angles are equal to each other. So it's usually these base angles right here. And then this one would be different. So next triangle we have is this one right here. Looks pretty nice. All right, I'll pause the video in 3, 2, 1, pause. And what's up? We back. All right. So the answer to this, the type of angle triangle this is wow. So we got a right scalene triangle. So we got a right triangle and a scalene triangle. How's it a right triangle, you might ask? Well, the square right here, you see, right here. So this is it shows that it is a 90-degree angle. And then there's scalene because all the sides are not congruent. See, all the sides are not congruent. All right, next. Next triangle we have here is this nice, I believe this color is turquoise. Correct me if I'm wrong. All right, so the answer, okay, no, not the answer there. So I'm gonna count down from 3 to 1. So let's get to pause the video. So we got 3, 2, 1, pause. And okay, welcome back to Too Much. All right, hello, we're back. All right, so the answers to this is an obtuse isosceles triangle. So it is obtuse because one of the angles here are over 90 degree, are greater than 90 degree. And it is isosceles because two of the sides are congruent to each other. So 16 and 16. Notice these two angles are equal to each other since they're isosceles. All right, next. Now we're moving on to quadrilaterals. Quadrilaterals, yes. What are quadrilaterals? A student might ask, or a child, or any age might ask. What are quadrilaterals? Quadrilaterals are 2D shapes / figures with 4 sides, 4 vertices, forming 4 angles, and the angles will collectively form 360 degrees. A lot of 4s, but say. So examples of quadrilaterals. Here we have squares. Here, I'm pulling up this. So we got squares, rectangle, trapezoid, rhombus, and kite. I might have accidentally said this as a parallelogram, but don't worry. A rhombus is a parallelogram. You'll learn this when you go up the grades. I believe when you go to 9th or 10th grade. So we got this quadrilateral song. As from my 5th grade section, it did not work, sadly. So I'll give you the link in the appendix section of this slideshow. So some practice. So we're gonna find the missing angle of shapes. So use the properties of quadrilaterals and triangles to find the missing angle. So we got here. So I'll give you a practice example so that you know what you're doing, so you're not confused. Don't worry, I got you. Okay, so we got this trapezoid, 35-degree angle, 145 is question mark. So I'm not sure if you learned this yet or not, but like this question mark would represent as a variable, and a variable is basically it just makes our life easier. Yeah, variable. Yeah, you'll learn it. I can't explain it well, but you'll learn it. All right, so as we know, the angles in a quadrilateral add up to 360 degrees. So then we add up all of these angles up, and also this. So just put the question mark right there, plus. So we got 35 plus 35 plus 145 plus question mark equals 360. Now you're gonna subtract this on both sides. So add up and then subtract 215 from both sides, which you see 215 from both sides, and then you get the question mark equal to 145 degrees. So your turn. If you're still confused, don't worry. Just at least try. I even give you like a hint or help for this. All right, ready? So pause the video in 3, 2, 1, pause. Hello and welcome back. So the angles, so with the answer right here. So as we know, the angles in a quadrilateral add up to 360 degrees. Since we have all three angles, you just add them up, put them in equation 36 plus 36 plus 144 plus question mark equals 360. Add up all the numbers. We don't add up the question mark. And then you should get 216. And then subtract 216 on both sides. And then you should get question mark equals 144 degree. So the unknown angle is 144 degree. Now, you might have noticed this or not, but do you realize that this angle right here and this angle right here are equal? And this angle right here and this angle are equal. So a future fact that you might have to learn in 9th or 10th grade is that in parallelograms, the opposite sides are the opposite angles are congruent to each other. So even in the last problem here, even the last problem, actually, I think I'm at my wait a minute. Oh wait, my bad. I might have confused up with this, but like this is a parallelogram, so it's different. But this, the trapezoid right here, is not a parallelogram. So it's not have the same properties. My bad. Sorry guys. All right. Next problem. So here we have a problem. This is a parallelogram. So you might know what to do. There's a shortcut for this, but you can add it up and do everything. So 3, 2, 1, pause it and return. And welcome back. All right. Or hello, actually, this time. So this time we got a diamond-looking shape, and I said that this is a parallelogram, so it's the same as this one right here. So if you want to solve the harder way, then you're welcome. You could do it any way you want. So we got 64 plus 64 plus 416 plus unknown angle equals 360. You add up all these numbers, gets 244 plus unknown angle equals 360. And then you subtract 244 on both sides. You should get 360 subtracted by 244. And then the unknown measurement should be 116. 116 as the unknown angle. So as I stated, that this is a parallelogram. And a parallelogram, the opposite angles are congruent to each other. What means is that this angle right here, the opposite angle from it is equal to it. So 116, 116, 64, 64. Right here, we have a triangle. So the parallelogram property can't work. Does not work here. So the drill, you know the drill. I'll count down from, I'll tell you to pause, and then once you finish figuring out the answer, then return back to, then unpause. I mean, all right, 3, 2, 1, pause. Hello, welcome back. Hello, welcome back. I want to change it up, you know. Okay. So next, so we should know that the angles in a triangle add up to 180 degrees. So this might be repetitive, but here. So you place 72 plus 49 plus unknown angle equals 180. Add up the numbers, 121 plus unknown angle equals 180 degrees. And then subtract 121 from both sides, 21 from both sides. And then you just get unknown angle equals 180 minus 121. And then you should get the unknown angle as 59 degrees. Next shape is the triangle again. So remember that triangle added up to 180. And then the same usual drill we always do. So 3, 2, 1, pause. Hello and welcome back. So now you should already have the answers. If you are confused about this, it's fine. You'll eventually get used to it. So the first numbers we got are, so we got 68 degrees, 44 degrees. And you might have noticed and confused why I added the side measurements for this triangle, specifically for this triangle. So you guys, okay, I'll tell you guys at the end of this problem the answer, but okay. 68 plus 44 plus unknown number angle equals 180. You add up these two numbers, it's 112, 112. 112, yeah. 112, yeah. Plus unknown angle equals 180. And then, oh, a typo error. This should be a subtract sign. I'll fix it. So we should have question mark equals 180 minus 112. So 112 minus on both sides. And then we got question mark, unknown angle is 68 degrees. So you might have taken a notice to what I said last time on Isosceles Triangle. You might have noticed that this is an Isosceles Triangle. That means that the two bottom angles right here, the base angles, are congruent to each other. 68 degrees equals 68 degrees. So keep that in mind, that the two base angles of an isosceles triangle are congruent to each other. Next, we got area of parallelograms. So we're moving on to parallelograms. Yay. So a parallelogram is a quadrilateral with pairs of opposite sides that are congruent to each other and parallel to each other. So the formula to find the area of a parallelogram is A equals BH, or I should say area equals base times height. So see right here, B equals base, H equals height. So here we have a parallelogram. So we got B, wait a minute, guys. So we got B at the bottom, and then H is the height. So when you're measuring the height of a parallelogram, you want to make sure that it's perpendicular. If the line right here is not perpendicular, that means that the height is not true. Some practice problems. So you might need a piece of paper, but Actually, you probably need a piece of paper. So grab out a piece of paper and a pencil / pen, or AKA any writing utensil, and solve these given problems. So the first problem, I'll go over it so that you'll get used to it, and then the next problem, you're gonna do it by yourself. So example, so find the area of this parallelogram. So we got this parallelogram right here. We got 14 centimeters as the height and 12 centimeters as the base. There you go. So we start off by writing out the formula: area equals base times height, A equals BH. And then we do plug it in or substitute it in. So 12 centimeters goes to base, B. 14 centimeters go to H. So then we get area equals 12 times 14. And then we get area equals 168 centimeters squared. Right here. Remember, it's important to leave your units in squared for area, because through my experience, don't ever leave the units out, because you might get marked someday by a teacher, marked off by a teacher someday. So yeah, your son. So find the area of this parallelogram. Here's a picture. All right. So I pause. Once you pause, so I'll tell you to pause it, and once you pause it, after you finish your calculations, then come back. So 3, 2, 1, pause. And welcome back. So hello again. So here are the answers. So we got A equals BH. Always write the formula out if you don't remember it, but if you remember it well, then you don't have to write it. We plug in 21 to B, plug in 9 to H, and then we get A equals 21 times 9. A equals 21 times 9. And area of this parallelogram is 189 meters squared. Next. All right. Again, so you got find the area of this parallelogram. So 716 feet. Yeah. All right. So pause. So when I count down to pause, finish everything up, and then come back. So 3, 2, 1, pause. And hello, welcome back. So here we have the answers. So A equals BH, and then we got plug in 16 for B, 7 for H, and then we multiply them together, and we should get area equals 112 feet squared. Next problem is we got this parallelogram with a, I believe that's a magenta pink, neon pink. Yeah. So find the area of this parallelogram, and I'll count down to pause. So 3, 2, 1, pause. And what's up? We're back. So the answer for this we should get is area equals BH. So A, plug in 27 for B, 8 for H, and we should get 27 times 8. And then area equals, and then once you multiply them, the area should equal to 216 inches squared. Now then, so we have a new coming up opponent. Originally, I wanted to show you an example, but this time, let's make it harder. So this may not look very familiar to you yet, but just try your best and pause the video and try to do this, and I'll meet you there. So 3, read out the equation. I want you to find the height of the parallelogram with an area of 176 centimeters squared. So pause it in 3, 2, 1, pause. And welcome back. I hope you guys figured this out, hopefully. So here, I'll show you. So first we set up the formula for this one. So area equals base times height. So we got the area is 176. You want to plug in everything, all the knowledge you have here. So we got we know that the area of this is 176 centimeters squared. And we know that the base of this is 16 centimeters. So you plug it in, 176 equals 16. And I replace the h, oh yeah, the h is x, yeah. And then in order to find this, you reverse everything. Like, I'm not going to explain this correctly, but basically you do the opposite. So basically, since 16 is multiplying by x, you want to divide 16 on both sides so that you get rid of this and leave the x by itself. And you should get 176 divided by 16. And once you divide that, you should get x equals 11 centimeters as the height. All right, another one. So find the height of this parallelogram with an area of 195 centimeters squared. Or actually, not centimeters squared, feet squared. And then the height is labeled as x, and then 15 feet right here as the base. All right, so pause the video in 3, 2, 1, pause. And welcome back. I hope you guys are not confused in this, hopefully. But if you're confused in this, don't worry. You got this. All right, the answers to this is, so we first get out the formula, A equals base times height. So when we do 195 equals 15x, but then I divided on both sides by 15 so that we can get the x alone. And once we get the x alone, we know what the height is of the parallelogram. So once you do this, all these calculations, you should get x equals 13 feet. And remember, label your units. This will help you not get marked off on the test. All right, so now we're finding the base of the parallelogram with an area of 144 meters squared. So we have the x right here as the base, and 24 meters. All right. So once again, with the process, pause, you hit pause, finish everything up, and then come back. So 3, 2, 1, pause. And welcome back. Welcome back. We got the answers right here. Hopefully you did this correct or attempted correctly. So we first start out with the formula. Area equals base times height. Once again, plug in everything. So don't mind these two 15s at the bottom. Mind these 144 equals x times 24. So then we plug x equals base into the base and 24 into the height. So then you should get 144 equals x times 24. And then if you want to, wait. I might have messed this up, guys. It's fine. Might have messed this up, but it's fine, guys. So this should not be divided by 15. So you should divide this by 24. My bad. Another typo. So divide this by 24 on both sides. And then you should get x equals 6 meters. Now we're moving on to area of triangles. The formula to find the area of triangles is area equals 1/2 times base times height. So the base and the height right here. Right here. Yep. Okay, ready? So we know that the base and height form a 90-degree angle. So you get the full height and everything. So here, let me just let this. Wait a minute. All right, let's look through this whole formula. So we have a right angle, we have an acute angle, and then we have, I believe that's an obtuse angle. Obtuse triangle, obtuse triangle, my bad. Okay, next. So I got some practice problems for you about the area of triangles. So you might, actually, if you've been using the same paper, writing utensil and everything, just keep using it. Just keep it there. All right, so example. Find the area of this triangle. So we got the triangle ABC. That's how you name a triangle. And then we got the height of 13 meters and the base of 8 meters. So then you just write out the equation, the formula. A equals 1/2. I forgot I didn't write the formula in, but you know, A equals 1/2 times BH, base times height. So we plug in 8 as our base and then 13 as our height. And then we get area equals 4. Since I didn't want to multiply 1/2 by everything once it was done, so you can multiply 1/2 anytime you want. So I decided to multiply 1/2 to 8 and get 4, and got 4. It should be 4 times 13. And then when you multiply 4 times 13, you should get area equals 52 meters squared. And now it's your turn. So find the area of this triangle with a height of 16 feet and a base of 14 feet. So pause in 3, 2, 1, pause. Hello, and we're back. So I got the answers for this. If you need the answers, I got you. We start out with the formula. A equals 1/2 times base times height. You substitute in, or AKA plug these numbers in. So 14 as the base, we plug in base. 16 as the height, we plug in as height. And then we remember to keep it 1/2. I always usually I multiply 1/2 to like numbers first. In the next step instead of at the end, because I feel like it's gonna be easier to multiply. So I multiplied 1/2 to 16 and got 8. So we got 14 times 8. And then 14 times 8 equals 112 feet squared. Now let's find the area of this obtuse triangle. So we got the height as 9 inches and the base as 17 inches. So pause the video in 3, 2, 1, pause. And welcome back. So I'll show you the answer now. So I always write the equation out, even though I messed up, but still write it out so you remember it in your head. So we got the formula of the area of triangles is area equals 1/2 times base times height. As usual, you plug in the 17 inches into the base and 9 inches into the height. And then you should get area equals 1/2 times 17 times 9. And then for this time, I did not want to multiply by 1/2 to everything because it would turn into a decimal or a fraction. Because those are, since 17 and 9, when times by 1/2, it will turn into, when multiplied by 1/2, it will turn into like a decimal or a fraction. So instead, I went this route right here where I multiply 17 times 9, 153, and you got 1/2 right here. And then when you multiply 1/2 to 153, you should get, if you're going to decimal, right, you should get 76.5 inches squared as the area. And if you're going the fraction route, then you should get 76.5 inches squared. So either way is fine. You can do decimal, you could turn it into fraction, as long as they're equivalent. Now we got a right triangle. So we got a base of 9 inches and a height of 11 inches. So pause the video and do what you gotta do in 3, 2, 1, pause. Hello, welcome back again. Now, it's time to show you the answers, review the answers. All right, so this is my work. So we got area, always write out the formula. So we got area equals 1/2 times base times height. Plug in base and height, you get A equals 1/2 times 9 times 11. And then I decided to multiply 9 and 11 before multiplying 1/2 to one of these two numbers because it will create into a decimal or a fraction. So I'll multiply 9 and 11 equals 99 times 1/2. And as usual, once you multiply 99 by 1/2, if you went with the decimal route, then you should get 49.5 meters squared as area. If you're going as a fraction route, you should get 49.5 meters squared. Next. Oh. Okay, so for this one, I might have messed this up. So I just explained this whole lesson, right? This whole thing, right? So for this one, I wanted you guys to find the height of the triangle with an area of 54 centimeters squared. So we got the base of 18 centimeters and the height as unknown. So the first thing I wrote out is the formula, which is A equals 1/2 times base times height. And then I plugged in what I knew, which is the area and the base. So we got plug in 54, plug in 18, and leave the h as h. Next, I multiply. Next thing I did was multiply 1/2 by 2. Because if you divide 1/2 by 1/2, it will be like 1/2 times 2 and 1. 2 over 1. So I multiply 2 over 1 on both sides so I can get rid of the 1/2 right here. And then this will create 108. And then we get 18h right here. So the next thing I did was divide 18 on both sides so I can isolate the h. And then you should probably get h equals 6. Or actually 6 centimeters to be exact. Now we got volume of cubes in rectangular prisms. The formula to find the volume of cubes and rectangular prisms is volume equals length times width times height. Or for short, V equals L times W times H. Notice, if you notice that all the edges of the cubes are congruent to each other, then you can create, if you notice that all the edges or the sides of the cubes are congruent to each other, then you can create the formula V equals S cubed. So this property is kind of the same as a 2D rectangle and a 2D cube, 2D square, I mean. So basically, since we know all the sides are congruent to each other, we can just cube the sides to find the volume. So here we got this is what a cube looks like with the length, width, and height and everything, even though they're all equal, all the sides are equal. And then we got rectangular prism right here. Looks like a 3D rectangle with a length, width, and height. So next. So you're gonna practice solving for the volume. So I gave you some problems, but the first problem, I'll do it and I'll show you what it's all about, so you won't be confused when you do this or try this. So we got this yellow cube with 8 inches all around. First, write out the equation. V equals LWH. You could use this equation or use the volume equals S cubed. Either way, it's the same. But I feel like it is easier if you went with the volume equals S cubed. Side cube, I mean. So we plug it in, 8 as the length, 8 as the width, 8 as the H, which is 8 times 8 times 8, or 8 cubed. And then we should get, once you multiply all these together, you get 512 inches squared. And then I show you the other route, which is way easier to write. So we got volume equals S cubed. So S is a side. And then you do volume equals 8 cubed. And then once you cube the 8, you should get 512 inches squared. Now let's find the volume of this rectangular prism with the dimension of 12 centimeters, 4 centimeters, and 7 centimeters. So the usual process we do is, pause the video, and once you finish solving this, come back for the answers. 3, 2, 1. pause. Okay, welcome back. Hello. So I believe you have tried this and hopefully you complete this. Here are the answers. So first I start off with volume equals length times width times height. And remember that the formula volume equals s cubed does not apply to this rectangle or work with this rectangular prism because all the sides are not equal. So we get volume equals 12 times 4 times 7. And then once you multiply all of them together, you should get 336 centimeters cubed. Now, find the volume of this cube. So we have one of the dimension labeled. I believe that's what it's called. One of the sides labeled. So we got 5 meters. So so pause the video, do whichever you need. So 3, 2, 1, pause. Hello, welcome back. Here are the answers. So we got volume equals length times width times height, length times width times height. And then we get V equals 5 times 5 times 5, which equals 125 meters cubed. And if you went with this route, you should get volume equals S cubed, volume equals 5 cubed, and then you should get 125 meters cubed. Now, find the volume of this rectangular prism. So here's a blue rectangular prism, and I'll pause it. You will pause it, and once you finish, come back, and I'll show you what I got. So 3, 2, 1, pause. And welcome back. So this is what I got. So we got volume equals length times width times height. And then volume equals 16 times 3 times 11. Once you multiply all of them together, you could use the calculator for this calculations. As long as you know what to do, you're fine. Just use the calculator. So this will make your life way easier. So you should get volume equals 528 feet cubed. Now, okay, another typo. This should be find this cube, not rectangular prism. This is a cube, by the way, not a rectangular prism. So this is a cube with 9 inches as one of the side. So I'll give you so let's pause. So 3, 2, 1, pause. And welcome back. So here are the answers. I showed my work. Volume equals length times width times height. And then you just plug it in 999. You should get volume equals 729 inches squared. Cubed. And if you went with this route, with this method of volume equals S cubed, then you should get volume equals 9 cubed. And then once you cube it, you should get 729 inches cubed. Now this is the end of the lesson of this lesson right here. If you want to stop here, you can stop. But if you want something more challenging, I got you. More challenging. Dare you take it, buddy? All right. Welcome to the hardcore mode. Hardcore mode. So next we're learning about circles. The parts of a circle include circumference, diameter, and radius. So as you can see here, it's being labeled right here. Circumference is basically the perimeter of this circle. Radius is a line segment that stretches from the center point of the circle to the perimeter of the circle, or the circumference of the circle. And then diameter is a straight line passing through the center of the circle and reaching to the other side of the circle. And you should know that diameter, that radius is half of the diameter, and radius is half of the radius is half of the diameter. Next. Circles. So this is gonna get really crazy, but stay with me. So if we divide the perimeter of the circle, or I should say circumference of the circle, divided by the diameter, then we should get this number, 3.141592654, and on and on. And on and on. So many mathematicians discovered this. So like they found out that if you divide the circumference by the diameter, you always get this number. Always. And this number is well known as pi, this symbol. You might have seen this, you might have heard this, but it's pi. It's not the food that you, pi is good, but like it's this symbol, this pi symbol. Pi, not P-I-E. Okay. And then now another concept. So if we take the circumference over the diameter, which equals 3.14, or pi, actually, I should say, if we take the circumference divided by diameter, it should equals the pi, simple pi. Simple pi, right? Divided, actually, yeah. If you times diameter on both sides like this, so circumference divided by diameter, if you times diameter on both sides, diameter right here, diameter times pi, you should get circumference equals diameter times pi. And diameter equals pi. And since diameter equals radius times 2, and since diameter equals radius times 2, then if you simplify this into a more usual way you see it, usually when you see it, the formula to find circumference is circumference equals 2 times pi times r. The 2 multiplying everything here is representing the 2, and the r is representing the diameter. So once you go in like the upper classes, like 9th grade and actually 8th grade, I believe, or 7th grade, you should find out the circumference equals 2 times pi times r. So next, so the area, in order to find area of a circle, you do area equals pi times r squared. Pi r squared, I should say. So practice problems you could do. So find the circumference of the circle. So, okay, I'll help you out with this one. First off, we find the radius, and we can find the radius by dividing by 2 or multiplying diameter by 1/2. You should get r equals 1/2 times 8, which equals 4 centimeters. So radius equals 4 centimeters. And then once you get the radius, you could pretty much solve this whole problem already. So you could do plug in, draw out the formula of in order to find circumference, which is c equals 2 times pi times radius. Plug in the radius where we found from here, where we solved. So we get circumference equals 2 times pi times 4. And then once you multiply everything out, if you did it in like the decimal form, then it might be harder, but I like doing this way because it's easier to label it and stuff. So you just multiply the 4 and 2 and just leave the pi as is. So we get c equals 8 pi centimeters, 8 times pi centimeters. So when you go into 9th grade, and actually 9th grade, I believe, or 8th grade, when you learn about circle, when the teacher says to leave the term in pi, this means that you just leave the symbol right here. You don't multiply 8 times pi, which equals some like long decimal. You have to write it out. It's annoying. It's never ending, actually. So just leave it in pi. In terms of pi, it'll make your life way easier. Now next. Now we're finding the area of the circle with the same circle from last time. So we got 8 centimeters as the diameter. So find the radius by multiplying 1/2 to the diameter and plug in the 8 times 1/2, and you just get 4 centimeters. Now area, once you get the radius, you pretty much can solve everything. So let's do this. So write out the area of a circle formula. So A equals pi r squared. You plug in the radius, which is 4, right here. So it's pi times 4 squared. And then once you square the 4, you get 16 times pi. So now you're gonna leave it. So the area should be equals. So the area should equal 16 times pi centimeters squared. So this is called leaving in terms of pi. This will make your life easier. So right here, wait a minute. Right here, leave it in the terms of pi. So we just leave pi right there and we're good. Next. Now then, your turn. So find the circumference of the circle. So you're gonna find the circumference of the circle and pause the video and solve this, and come back when you have it, or when you're confused. Then yeah, so I'll count down 1, 3, 2, 1, pause. And welcome back. So if you tried out this problem and if you're confused, it's fine. You get used to it. This is a hardcore challenge for a reason. So first, we find the radius, 10, right here is the diameter. Just times 1/2 to the diameter, and you find radius. And plug in 10, and you get 1/2 times 10. And the radius should equal 5 meters. And for the circumference, once you have the radius, just plug it in. Plug in the radius in the formula of circumference, and write out the circumference. The formula of circumference should be C equals 2 times pi times radius. C standing for circumference. Plug in the 5 as a radius, so equals circumference equals 2 times pi times 5. Multiply 2 and 5, you should get 10 times pi. And then the circumference will be 10 times pi meter. 10 pi meter, I believe that's how you say it. 10 times pi meter is the circumference. So as again, leave it in terms of pi, which means just leave the pi symbol right there. You don't have to multiply 10 pi to get some ridiculous, not ridiculous, but to get like a long decimal. Now this should be find the area, not the circumference. Once again, a typo. So this should be find the area of a circle, not the circumference. We already did that. Find the area of the circle. So I'll leave you guys. So hit pause when I say pause so that you can solve this equation, this problem. And 3, 2, 1, pause. All right, welcome back. So as the usual method, we should solve for the radius. Radius equals 1/2 times diameter. 1/2 plug in 10 as diameter. So radius equals 1/2 times 10, which equals 5 meters. So radius is 5 meters. And then you write out the area formula, which is area A equals pi times r squared. Area equals pi r squared, pi times r squared. And then you should plug in 5 for the radius, and then you just get pi times 5 squared, and then square root of 5, which gets you 25 pi meters squared. So the area should be 25 pi meters squared. And once again, leave it in terms of pi. This will make it easier. This will make your life easier. You don't have to write many things, you know. Now, another problem. So find the circumference of this circle. And 3, 2, 1, pause. And welcome back. So after you have finished finding circumference, here I'll show you my work to make sure you get it correct. So we got r equals 1/2 times d, and then plug 12 in for diameter, which gets you 1/2 times 12, and the radius should be 6 feet. And then you should get 6, and then you should write out your formula for circumference, which is c equals 2 pi r. Circumference equals, plug in the 6 as your radius. So c equals 2 times pi times 6. And then circumference of the circle should equals 12 times pi feet. Okay. Now, this is a typo again. Oof, so many typos. Sorry, guys. So for this one, you want to find the area of the circle, not the circumference, the area of the circle. So find the area of the circle with a diameter of 12 feet and come back. So 3, 2, 1, pause. And welcome back. Hello. First thing we're gonna do is write out the equation to find radius. So r equals 1/2 times d. Plug in diameter 12 times 1/2, and you should get radius equals 6 feet. Now write out the area, the formula for the area of a circle, which is area equals pi r squared. Pi times r squared. Yes. Plug in the r, plug in the radius, which is 6 feet right here. Plug in 6. So it should be pi. So area should equal pi times 6 squared. And once you square the 6, you should get area equals 36 pi feet squared. Now, so this lesson has been ended, is to its end. So now we have the appendix. So these are like videos that can help you have a clear understanding about the subjects you just learned. For example, for this YouTube video, it will help you understand more about circles right here. And then for this video, this YouTube video, this will help you understand clearly about volume. And if you really need help on one of these subjects or like lessons, units, whatever you call it, then there's a website called Academy that has videos that might help you in math lessons, and they also have some practice problems for you, for some practice problems to help you remember all these things. So here's a link to 7th grade geometry. So just look to it, have fun, and yeah. And the way bottom one for volume and area, that's for if you need help for volume and area, and then click that. It'll pop up a website. It's called Academy, and enjoy your time there. And we have about the author. Okay. Hello, it's me, the author. My name is Anton. I am 15 years old, about to be a sophomore in high school. I like to sing songs, learn about music theory, and in the near future, I would like to become a song creator that can positively influence people through my songs. And hope you guys can enjoy your day, and see ya. Bye.